The 2005 codebook states that cables installed over 2400 volts must be shielded. Non-shielded cables will now be printed 2400 volts and not 5000 volts as had been the standard. The enforcement of code requirements can vary depending on the jurisdiction and the specific inspector. However, the 2005 codebook requirement for shielded cables over 2400 volts is generally being enforced by code inspectors. The decision to change the voltage level at which shielded cables are required was made for several reasons. Firstly, the increased use of high-voltage equipment in commercial and industrial applications has increased in recent years. This has led to a greater need for shielded cables to protect against electromagnetic interference, or EMI. Secondly, advances in cable insulation materials have made it possible to provide better protection against EMI without the need for shielded cables in many cases. Thirdly, shielded cables are more expensive than non-shielded cables. By raising the voltage level at which shielded cables are required, it is possible to save money on cable installations. Code inspectors are primarily concerned with ensuring that electrical installations comply with the requirements of the code. They may consider the recommendations of organizations such as Underwriters Laboratories, but the code ultimately takes precedence. In this specific case of shielded cables, the 2005 codebook requirement applies to all cables installed over 2400 volts, regardless of whether they are Underwriters Laboratories listed. It is the responsibility of cable manufacturers to ensure that their products meet the requirements of the code. If a cable is not specifically listed for use over 2400 volts, it should not be used in such applications. Let's delve deeper into each of these aspects. Shielded cables are designed to contain electromagnetic fields within the cable and prevent external electromagnetic interference from affecting the signals transmitted through the cable. This is particularly important in high-voltage applications, where strong electromagnetic fields can be generated. The shielding typically consists of a conductive layer, such as a metallic braid or foil, that surrounds the cable's conductors. This conductive layer is grounded, providing a path for electromagnetic currents to flow back to the source, effectively containing the electromagnetic fields. The 2005 codebook update reflects a broader understanding of the risks associated with high-voltage installations and the need for enhanced safety measures. By lowering the voltage threshold for requiring shielded cables, the code aims to provide an additional layer of protection against potential hazards. This change also aligns with the increasing use of sensitive electronic equipment in various industries, which are susceptible to electromagnetic interference. Electromagnetic interference can disrupt the operation of electronic devices, leading to malfunctions, data loss, or even system failures. Shielded cables help to mitigate these risks by reducing the amount of electromagnetic interference that reaches sensitive equipment. The advancements in cable insulation materials have played a significant role in the evolution of cable technology. Modern insulation materials offer improved dielectric strength, heat resistance, and chemical resistance compared to older materials. These improvements have allowed for the development of non-shielded cables that can safely operate at higher voltages in certain applications. However, it is important to note that even with improved insulation materials, shielded cables still provide a higher level of protection against electromagnetic interference. The decision to raise the voltage level at which shielded cables are required also took into account the cost implications of cable installations. Shielded cables are generally more expensive than non-shielded cables due to the additional materials and manufacturing processes involved. By focusing the use of shielded cables on applications where they are most critical, the code aims to strike a balance between safety and cost-effectiveness. Code inspectors play a crucial role in ensuring that electrical installations comply with the requirements of the code. They are responsible for inspecting electrical work to verify that it meets the minimum safety standards. Code inspectors have the authority to issue citations for violations of the code and can require that non-compliant installations be corrected. While code inspectors may consider the recommendations of organizations such as Underwriters Laboratories, their primary responsibility is to enforce the code. The code is a set of rules and regulations that are designed to protect the public from electrical hazards. Underwriters Laboratories is a private organization that tests and certifies products to ensure that they meet certain safety standards. Underwriters Laboratories listing is not a substitute for compliance with the code. Cable manufacturers have a responsibility to ensure that their products meet the requirements of the code. They must design and manufacture cables that are safe and reliable for their intended applications. Cable manufacturers must also provide clear and accurate information about the specifications and limitations of their products. If a cable is not specifically listed for use over 2400 volts, it should not be used in such applications. Using a cable in an application for which it is not rated can create a safety hazard. In summary, the 2005 codebook requirement for shielded cables over 2400 volts is a significant safety measure. The decision to change the voltage level at which shielded cables are required was made for several reasons, including the increased use of high-voltage equipment, advancements in cable insulation materials, and cost savings. Code inspectors are responsible for enforcing the code, and cable manufacturers are responsible for ensuring that their products meet the requirements of the code. When working with high-voltage electrical systems, it is essential to follow all applicable codes and regulations to ensure the safety of people and property. Always consult with a qualified electrician or electrical engineer for assistance with high-voltage installations. Consider the specific context of the electrical installation when determining whether shielded cables are necessary. Factors such as the proximity of sensitive electronic equipment, the presence of other sources of electromagnetic interference, and the overall risk assessment should be taken into account. Remember that even if a cable is not required to be shielded by the code, it may still be beneficial to use shielded cables in certain applications to improve the performance and reliability of the electrical system. Stay informed about the latest updates and revisions to the electrical code. The code is constantly evolving to reflect new technologies and safety practices. Regularly reviewing the code and attending training courses can help you stay up to date on the latest requirements. The information provided here is intended for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified expert before making any decisions about electrical installations. Shielded cables are constructed with a metallic layer, typically copper or aluminum, that surrounds the inner conductors. This metallic layer acts as a barrier, preventing electromagnetic radiation from escaping the cable and interfering with nearby electronic devices. It also protects the cable's conductors from external electromagnetic interference, ensuring signal integrity. The effectiveness of a cable shielding depends on several factors, including the type of shielding material, the thickness of the shielding layer, and the grounding method. Cables with braided shielding generally offer better protection than those with foil shielding. The shielding layer must be properly grounded to provide a path for electromagnetic currents to flow back to the source. Without proper grounding, the shielding can become ineffective and may even act as an antenna, radiating electromagnetic interference. When selecting shielded cables, it is important to consider the frequency range of the electromagnetic interference that needs to be blocked. Different shielding materials and designs are more effective at blocking different frequencies. For example, cables with multiple layers of shielding may be necessary to block a wide range of frequencies. The 2005 codebook update reflects a growing awareness of the importance of electromagnetic compatibility, or EMC, in electrical installations. ENC refers to the ability of electrical equipment to function properly in its intended electromagnetic environment without causing interference to other devices. Shielded cables are an important tool for achieving ENC in high-voltage installations. In addition to shielded cables, other techniques can be used to reduce electromagnetic interference, such as using filters, surge suppressors, and proper grounding practices. A comprehensive EMC plan should be developed for any electrical installation that involves sensitive electronic equipment. The cost of shielded cables can vary depending on the type of cable, the shielding material, and the quantity purchased. However, the cost of shielded cables is generally higher than the cost of non-shielded cables. When evaluating the cost-effectiveness of using shielded cables, it is important to consider the potential costs of electromagnetic interference, such as equipment malfunctions, data loss, and system downtime. In some cases, the cost of shielded cables may be justified by the reduced risk of these problems. Code inspectors play a vital role in ensuring that electrical installations are safe and compliant with the code. They are trained to identify potential hazards and to enforce the code requirements. When inspecting electrical installations, code inspectors will typically check for proper wiring methods, grounding, and overcurrent protection. They will also verify that the correct types of cables and equipment are being used for the intended applications. If a code inspector finds a violation of the code, they may issue a citation and require that the violation be corrected. Failure to correct a code violation can result in fines or other penalties. Cable manufacturers are constantly developing new and improved cable products. These advancements are driven by factors such as the increasing demand for higher performance cables, the need for more environmentally friendly cables, and the desire to reduce cable costs. Cable manufacturers work closely with organizations such as Underwriters Laboratories to ensure that their products meet the latest safety standards. They also conduct their own testing and research to develop innovative cable solutions. When selecting cables for an electrical installation, it is important to consider the specific requirements of the application. Factors such as voltage rating, current carrying capacity, temperature rating, and environmental conditions should be taken into account. Always consult with a qualified electrician or electrical engineer to ensure that the correct cables are being used. Remember that electrical safety is paramount. Always follow all applicable codes and regulations when working with electrical systems. If you are not qualified to perform electrical work, hire a licensed electrician. The use of shielded cables in high voltage applications is a critical safety measure that helps to protect people and property from electrical hazards. By understanding the reasons behind the 2005 codebook update and the role of shielded cables in reducing electromagnetic interference, you can make informed decisions about electrical installations.